Hi guys! In this lesson, I'll explain the working principle of the zener diode, which is used for voltage stabilization in electronic circuits. Zener diode is a diode that keeps the voltage applied to its pins constant. When zener diodes are connected to the circuit in the right direction, it works like a normal silicon diode. In other words, they start to flow current after 0.7 volts. But they are not used that way. They are used in reverse connection to the circuit. When connected in reverse, they do not flow current up to a certain voltage value. This voltage is called break or zener voltage. After the breaking voltage, they start to flow current and the voltage value on them remains constant at the breaking voltage value. In fact, we can say that it is a diode that flows current in both directions. They do the job of a voltage regulator. Their color is usually orange with a black stripe at the cathode tips. The symbol is like this. Now let's look at some examples to better understand the working principle. The zener diode, which finds a variety of applications in order to provide a constant reference voltage or for protection purposes, appears in many electronic circuits. Therefore, there are zener diodes in many circuits that undertake the functions of voltage stabilization, signal clipping, electronic element protection. To better understand the working logic, I built a circuit where the resistor and two zener diodes are connected in series. Here, there are zener diodes 1N5231 with a zener voltage of 5.1 volts and 1N4728 with a zener voltage of 3.3 volts. When we connect a 9-volt source to this circuit and measure the voltage falling on a zener diode with the help of a multimeter, we see the zener voltage of that diode. If we make the source 12 volts, the measured voltage will still be 3.3 volts. If we measure the voltage across the two diodes, we see the total zener voltage. In the same way, even if we make the source 12 volts, the voltage will still be constant 8.4 volts. Zener diode is used in this way to ensure that many circuit devices operate at a certain voltage. In this case, the element used will only work at voltages exceeding the zener voltage. Thus, they keep the voltage to the load constant and protect the load from excess current. So, what will the zener diode protect against high current? There is only one thing that can be done in this regard, and that is to connect a big series resistor of suitable value in front of the zener diode. In this way, the zener diode is protected against high current. Let's do one more example. Here, you can see that three zener diodes with breakdown voltages of 5, 3, and 10 volts are connected in reverse and in series. A normal silicon diode is also connected. If we measure from this point in the circuit, we see the breaking voltage value of the zener diode, 10 volts. For example, if we take an output from here, we get 8 volts output from the total breakdown voltage value of 5 volts plus 3 volts. If we take the output from here, we get 10.7 volts from 10 volts plus 0.7 volts. Finally, if we take output from all of them, we can get 18.7 volts output value from the sum of 5 volts plus 3 volts plus 0.7 volts plus 10 volts. As you can see, we can get the voltages we want thanks to the zener diodes. With this logic, adjustable voltage sources are made. The current voltage graph of the zener diode is as here. In the case of forward polarity, that is, when it is connected straight, it starts to pass current after a voltage of about 0.7 volts like a normal silicon diode. In the case of non-reverse polarity, it starts to pass current after the breakdown voltage and starts to regulate. When we connect the zener diodes in series, we can increase the regulation voltage. For example, when we connect two zener diodes with a breaking voltage of 5 volts in series, we can obtain a regulation voltage of 10 volts, and similarly, we can increase the power when we connect zener diodes in parallel. For example, when we connect two 0.5 watt zener diodes in parallel, we can provide a constant voltage to a 1 watt load. Zener diodes are used not only as a regulation process in direct current, but also in clipper circuits for clipping operations at the desired value in alternating current. As in the examples here, the sign-shaped AC input voltage is clipped at the output by means of zener diodes. If zener diodes actually do the job of voltage regulators, you may have a question why zener diodes are used. This is mainly due to the lower price of zener diodes. Here, you can see the zener diode and voltage regulator sample price comparison that can do the same job. For a single one, these price differences may seem like very little, but in industrial applications where we need to use a lot, this ratio becomes important. This is the basic structure and working principle of the zener diode. I hope it was helpful and you liked it. Hope to see you in the next lesson. Goodbye.